When I was faced with the decision on what to study, one of my key inspirations was the innovative leadership team behind the startup Lilium. Lilium's founders were all students when they came up with the idea of an electric air vehicle. Their fight for sustainable and autonomous air mobility motivates me up to this day to launch a startup and bring my ideas for more efficient, sustainable and inclusive engineering solutions into the world.
Today I study aeronautics with spacecraft engineering at Imperial College London.
At Imperial, I have held multiple leadership positions in the last years. As the project leader in the Wind Turbine Design Challenge, I was responsible for the coordination of the team, making sure that every task is completed in time, every decision is properly discussed and communicated, and lastly holding up the team spirit. As the airframe sub-team lead of the Imperial rocketry team, I have successfully led the first test launch of our first rocket, Apogee, and secured sponsorships from companies such as Autodesk and Airbus. As the Aero Society Industrial Liaison Officer, I took the initiative and organized the space engineering competition SpaceHack 2019 in cooperation with OneWeb. Over 100 students grouped into individual teams competing in space engineering challenges such as space debris removal.
3, 2, 1.
My second major contribution to the society was getting in touch with ESA astronaut Dr. Andreas Mogensen. I invited him to Imperial to give a guest talk for more than 250 students about his experiences in space on the ISS. Getting to know him was a very inspirational moment to me. Last year, me and my team designed the Ventus V111, a conceptual 250 passenger aircraft. During the project, I've learned the importance of balancing trade-offs in the design process to ensure that our goals and constraints are met. In my latest role, I was leading the structural design team of the Mass Transit Vehicle project. By coordinating the conceptual design selection and communicating with other sub-team leaders, I learned how to effectively work and lead within a big team of engineers. I have also gained a lot of practical experience during internships and placements in the industry. I made my first encounter with data science and machine learning as an intern at BMW, where I was investigating powertrain failure data from BMW cars all over the world. At the German Aerospace Center DLR, I was involved in the preparation of several experiments of deployable space structures on a zero-gravity test flight by DLR and NASA. I developed a rope pull system for the controlled application and measurement of deformations and designed a deployable modular solar array prototype. As an intern at the European Space Agency, I worked on the assessment of the impact of satellite megaconstellations like Starlink by SpaceX or OneWeb on astronomical observations by the Hubble Space Telescope. I trained a deep learning algorithm to find out what fraction of Hubble images are affected by satellite traits. Currently, I'm an intern at Airbus Defence and Space, where I'm working on a concept of cloud computing and artificial intelligence solutions for defense applications. In May, I will start a research placement at NASA's Jet Propulsion Laboratory, where I will work on robots using artificial intelligence to work as an autonomous team to explore the lunar surface, collect data, and map different areas of the moon in 3D. I strive to become an innovative engineering leader by launching a startup with the aim of developing AI tools for engineering and science applications. I'd like to explain one aerospace use case example to demonstrate how the startup could contribute to a sustainable society. Commercial aviation has a significant contribution to climate change. It accounts for about 2.5% of CO2 emissions, but airplanes also have other warming effects due to NOx emissions, vapor trails, and cloud formation. Reducing fuel consumption is one of the key tools we have to make aviation more sustainable. This could be achieved by using AI for flight route optimization. Big data machine learning algorithms can be used to analyze a large quantity of data on each flight coming from black box data recorders, weather recorders, and airline traffic plans. The AI tool can then provide guidance and a series of recommended actions that airlines and pilots could implement to lower the fuel consumption. It's a great honor to apply to the ELS program. I hope you enjoyed this video, thank you for watching and take care.